All right. We're back. And as you can see, I've done a little bit. Since the last stream, I locked in a little bit. I got texture loading set up. And now we have terrain based on height maps. It's pretty cool. I also, again, redid the flight controls, and now they are much better. I fixed some pretty frustrating bugs. This is all running in the browser, by the way. I probably should make that like smoother, but you know what? That's a minor thing. And I think we're actually reaching. Oh, the sun works too, by the way. Fix that. It actually looks surprisingly good. But right now, we actually have the makings of a somewhat legitimate flight simulator. And if I slow down, I can kind of glide really slowly. A little risky. All right, we're gonna speed up. But that's where we're at right now. And it's pretty stinking cool. But for today, hey, what's up, dude? For today, what we're going to be working on a little bit. First thing, I want distance-based fog. This terrain actually is big enough to probably serve as the map, so I might have accidentally next flight simulator. It'll be a flight simulator. I don't know if it'll be the flight simulator. I'd love it to be, but it hopefully will be the browser flight simulator. You know, I don't really see a whole lot of these. The sun works pretty well. Whole skybox is procedural, so we can change whatever colors we want. Maybe we'll have a dynamic day-night cycle. Today, what we're gonna get working on some distance-based fog. We're gonna get working on, I don't want to get working on sound effects because sound, I'm gonna have to go and make a bunch of sound files, and that's not gonna be fun to do. I'm not gonna do that on stream because making that stuff's boring to me. But, so distance with that, we might begin working on water. That might be something to start doing. I'm going to get font rendering working off screen. Oh, we also need to actually implement the concept of velocity into this engine because right now, my throttle is my airspeed. Like, if I set the throttle to 0, my plane will instantly stop. There's no difference between throttle and how fast the plane's moving. So I need to create that concept because then we can implement stalling, which might be what we work on next. Of course, stalling will be interesting. That'll be a whole thing in itself. Maybe that's what we do today. Maybe we work on some distance-based fog, and then we implement stalling and like actual airplane velocity. And then we might work on the water plane. The water plane will be a little bit of a hassle, but I seem to be starting this stream much more on time, so we might have some extra time to work on that. Things I want before I release this demo, because we're actually getting there. First thing, ideally I want some particle systems. There's nothing coming out of the jet engine exhaust, and that's got to change. I want like particles flying over the body of the aircraft when you pull a lot of G's, like the little air streams. And I want those little smoke streams coming off the tips of the wings when you do aggressive flight maneuvers as well. So it looks fun. Thanks, man. You'll be able to play it soon, I promise. And then I also need sound. So here's what we need. Before launch, we can have the water plane later. Like, all that's not necessary. Before launch, we need fundamentally particle systems. That's the most fundamental thing. We could actually implement particle systems a little bit today. I've had some thoughts as to how I want to do it. It might be hard. We might not finish it. But we need particles. Because if we can get particles, we can get exhaust. We can get the wisps of air off the tips of the wings. And we can get the air going over the body of the plane on high G-force. Okay, maybe we change our priorities. Maybe our priorities are, first, aircraft velocity and the concept of like velocity for the aircraft and stalling. Then we start working on particle systems. That actually doesn't sound like a bad idea. And then after that, I'll do all the other fancy stuff like water and text and font rendering. And sound effects will be the other thing. So once we have sound effects and particles, fundamentally, sound effects, particles, and airplane physics completed. And this thing will be live for our first live demo. And because it's like a browser thing, I'll literally just have to just host what I have here, and anyone can play it at any time. Like, it's not going to be like a beta test where like you can only play it at certain times. I might have to do something like that when I'm doing with like multiplayer stuff. Collision. Yeah, that we'll worry about collision later. Actually, because this is like a height, collision should actually be really easy to implement because I'm using a height map for this terrain. So it really should just be like getting the local coordinates of the terrain, of the texture, and then all that stuff. Can a plane accelerate? It can. It can accelerate and decelerate. So I can slow down, and I'll start to fall if I go below a certain airspeed. And I can kind of glide if I'm really slow. And if I speed up more, I can do that. There's also a brake. It doesn't do anything just yet, but the air brake is there. So I think airplane physics, particles, sound effects. We will not do collision off the bat, because realistically, the only thing you're going to collide with in this game is other planes and the terrain. So it actually should be pretty easy. What won't be easy about that is we're going to have a whole death cycle and a spawn cycle. That's what will be the kind of frustrating part with that. So we're not going to just do that. The player has to go somewhere when he dies, you know. 2 servers, 1 for multiplayer coding, 1 for hosting. Yeah, exactly. That's what I'll have to do when we actually test the multiplayer stuff way down the road. But you know, like I won't have that running all the time. So like the actual multiplayer tests may have to follow like a beta test cycle kind of thing. But the actual flighting, like this flight demo, once I host this, you can do it whenever. So yeah, let's get to it actually. This is really, really solid stuff, I would say. All right, so let's close that. This is how I've been getting the terrain height maps too. So this terrain height map just spits out a 16 by 16 image. I'll close out all my zoom stuff. Anyway, all right. First thing to implement, aircraft physics. Right now, really the only thing we need is a sense of air speed. You're not really going to be like tumbling through the air too much. Okay. Probably should be public, because we might want to read from that. Float air speed. All right, equals 0.0. And then our throttle, let's see. Yeah, so our throttle, this is where our throttle controls are handled. Hey, I recognize your name, Yolo. Como Mexicanos. What's up, dude? Let's see. Yeah, you're gonna host it for free. Aspire players who play the game single player. Yeah, well, in the beginning, it's gonna be 1v1s off the bat, and then I want 16-player lobbies. 16-player lobbies. 60 would be too much. Although who knows? Maybe I optimize the hell out of this thing, and it gets to that point. All right, throttle unrotated. So right now you can see our throttle is directly influencing like all of that. That should be airspeed. So what we need is our throttle then applies to our airspeed. So our airspeed shouldn't just be instantly linked. Well, we could just lerp the airspeed to whatever the throttle is. What up? Hey, what's up? I'll play this again because Formula Center is a friend, and I've done a lot since yesterday. Okay, I kind of went crazy last night. The sun works. Terrain now loads from a texture. Aircraft works. This is starting to kind of look like a game. So today, what we're going to be working on is we're going to get stalling and that kind of aircraft physics in play, and then after that, we're going to start working on particles. Because once we have particles and sound, this demo should be ready. Which is easier said than done, but I think I have some ideas. So the airspeed, let's see. Airspeed should not be clamped between 0 and 1. That's the problem. Okay, let me think how we want to do it. Love the train. Thanks, I love the train too. Yeah, I don't want to clamp the airspeed. That feels wrong. Because airspeed isn't... Airspeed is just however fast you're moving. The sun is not a triangle. The sun is now working. Everything's working. We could just lerp... You know what? No, that feels wrong. We don't really have a concept of physics in this engine. Or like force or any of that stuff. Airspeed... Okay, so airspeed is just a concept of the faster you move, the more friction there is. So if our throttle's at max, we will like stop at a... We could just lerp to whatever the throttle is, honestly. That could be somewhat valid. And then we could just control how much we actually lerp to it, depending on like... it still feels wrong. Maybe there's like an air acceleration factor. Forward acceleration. That's what we should get. Yeah, we need some concept of that. So smooth mouse delta. Where should we put it? None of this stuff is related to each other. Roll value, float, forward, acceleration. Yeah, that would be totally different. It's force. There's no forces in this. So which I will say, because I'm not actually using physics, technically the multiplayer should be easier, because physics makes multiplayer hard. But because we're not using any physics and everything's deterministic and just like working through code in the engine, like multiplayer should be easier because of it, at least in theory. So I don't want to lerp the airspeed to that. Well, what do you think about increasing? Yeah, I got no problem with that, bro. I'm so sorry. Is that better? That's probably better. Okay, so we have throttle. Right now we're just reading directly from the throttle, which should not be the way things work. The airspeed should be not lerping to the throttle. Right now the throttle just determines our max speed. Well, because our max speed is just a variable that we can set, lerping, you know what, for now, make it work now. Yeah, exactly. So actually, maybe we don't need an airspeed. Maybe instead what we just need is force, thrust. And the thrust will just be a thrust factor. It's not actually like accurate. Thrust factor equals math utils lerp float thrust factor controls dot throttle, and then we'll do it time delta time times what? We're gonna want this to be pretty snappy. Although that that could be a setting. I don't like hard coding magic values. And then here thrust factor will be what we use instead of anything else. Throttle cruise. Wait a minute. Oh, throttle cruise is just whatever our cruise throttle like whatever minimum throttle setting we can fly at. What's up, dude? And then that should just like leave it the exact same. But now how we implement that thrust factor can be... Okay, so it seems to work the same. But now we can do a couple other things. So the starting speed is just set to whatever the throttle is. Although this should probably be a little slower. Anyway, stalling is because, you know, you can't just fly straight up. Right now, this would just let us fly straight up. So we need a concept of how upwards we're facing. So we'll say float up dot equals GLM, the dot product of our unrotated forward with global up, and that'll just tell us like how upwards we're facing. Depending on how upwards, and we also want that from 0 to 1. Ironically, GLM doesn't have a clamp method, I don't think. So I had to write my own. Honestly, very surprising. And we want this 0.0 to 1.0. Okay. And we'll build that. And then this up dot, depending on how upward we're facing, there's like a, we're going to progressively be slowing down when we go up. So realistically, we're going to progressively be slowing down at, my brain is just fried trying to think about this like off the dome. But based on this, because the throttle's a factor from, I have an idea. Float throttle minimizer will be up dot divided by 4. Make this a fourth of the strength. And then we will simply, like, depending on how upwards we're facing. Actually, realistically, we want to decrease our thrust factor. So our thrust factor will be lerp that. Thrust factor will minus equal throttle minimizer. All right. This is probably going to break everything off the bat, but that's okay. And basically, the more upwards we face, so the more downwards we face, everything should work just fine. Like that. If we face upwards, though, yeah, that works. That works. It's way, way, way too aggressive, but the concept seems to work. If we face upwards, like, we're not just going to be able to infinitely fly upwards. Like, face straight up. You can see we're kind of going down. And then if we face, like, level, that's great. Nothing's really happening. And we face straight up, we should start falling. Yeah, we're falling. It's not what we like, still way too aggressive, so we're gonna have to like fine-tune this a little bit. But if we really, really crank this down, pointing straight up will cause us to stall. We can fly upwards, that's good. Fly straight up, what happens? We're still able to fly straight up. So here's another thing we can do to tell what's going on. Depending on how similar our thrust factor and our throttle is, thrust factor seems like the wrong name. Yeah, because, let's see. Target thrust. Applied force would be better. Because the thrust factor, like, that makes it sound like it's the engine. It's not. Applied force. All right. So the other thing is, depending on how similar or different the applied force is from the thrust factor, we can lerp where the plane is facing. So if we stall, like, our plane's not just going to keep pointing straight up. It's going to probably flip and fall pointing straight down. So we need move offset. That's all correct. Transform that rotation equals that. Rolling, all that stuff. Yeah. So this is really where all of the last modification to the transform happens. So depending on this stalling logic, depending on this, if our thrust factor is throttle minimizer, let's first figure out what this is. Not throttle minimize, applied force. And then once we know what numbers we're dealing with, we can we can actually determine where we'll stall, what that kind of stuff looks like. So let's see. If we point straight up. Oh, look at those numbers. They're slowing down. Not quite enough. It's still going up. So maybe like 70 feels like a constant. We'll have to make this a symbolic constant too at some point. Like, anytime we're tuning something. Okay, let's see. So we're at 0. We're still pretty much able to increase our... Wow, that changes a lot. Maybe 150. Maybe we didn't compile, honestly. Maybe that's just what happened. But basically, if we're at whatever that The higher this throttle, minimize. Let's see. That's better. Not quite, but better. There's kind of an equilibrium being reached. But if our throttle, do we just want it to make it like face down? We don't want it to always face towards its velocity. Obviously. Let's see. We have max throttle right now. Throttle minimizer. Wait a minute. Are we debugging the wrong thing? I'm so sorry about that. Why is it going down? Isn't it just slow down? No, it's not. It's not slow down. We need this to fall out of the sky if its airspeed gets too low. And that airspeed needs to be affected by how upwards it's facing. So like, that's our applied force right there. It is going up, but it goes, it follows, see that number down there that I'm logging? Right now the throttle's at max. It is going to try to match what the throttle is at. But if we point it straight up, it's going to struggle to reach that throttle value. And the reason for that is because we want the plane to not just be able to fly straight up without, like, consequences, you know? Like, flying straight up isn't something planes can just do. So if we fly straight up, look at that. We're starting to kind of stall. Like, we fly straight up, look at that. Thrust factor is now negative. We're falling. But if we point down at the ground, our thrust factor fixes itself and we get out of the stall. See? So really, that actually might just be it. We might have just gotten the stalling working. And if we set our throttle to max, you know, we've set our throttle to max. And what this also means is naturally your plane is going to kind of fall a little bit, which is accurate. Max throttle, this is pretty good. But if we go straight up with max throttle, like, you're never going to be able to just do this unless you have a really strong thrust to weight, which maybe this plane hasn't. Maybe this plane has that. Full throttle does seem, it's kind of working. We need to play around with the numbers a little bit because full throttle seems to still let us fly straight up. So the last thing we need is when you stall, your plane doesn't just keep pointing straight up. Your plane points down. Or at least it tries to follow your velocity. So when we stall, we want our plane to try to face downwards. Look at that. So our throttle is max, and we're still kind of able to just go straight up, which is a problem. So 150. Which, yeah, sometimes it's not working. Well, the reason it's not working is because I was testing it at 50% throttle, and I didn't realize it until just now. So right now we're at full throttle. If we try to go straight up, we should fall. Should take a little bit. You can still gain altitude, right, though? Well, no, not if you're like, yeah, you can gain altitude, but you shouldn't try to gain altitude by going straight up. Like in a jet, you should try to gain altitude by going at an angle, yes, but not straight up. So we're just playing around with the values until going straight up causes you to stall. Unless you just have an aircraft with a just truly incredible thrust-to-weight ratio. I don't think this built. No, it did. And once we have the stalling logic set up, then we just need the plane to kind of lerp downwards. 200. Wow, this thing really actually does have a lot of thrust. Like, maybe let's really crank this up. Toying around with values and having to recompile the engine is kind of frustrating. That's one of the advantages game engines give you, is you can change something, then the editor instantly reflects that. Let's see. We're going straight up. I'm an idiot. Throttle minimize. We'll do like 70. And then based on that, we'll lerp downwards. Which I think I already kind of know how I'm going to do that. So we're going up. I'm going to point straight up. And I can see we need that number to keep going down. Keep going down. No, it's still able to climb with that ridiculous level of... And again, you know what? We're not really going to be like landing in this game. So we don't need like truly realistic flight physics. Look at that. That's too much of a stall. But like, look, you can climb. Although that's a little too aggressive of a stall factor. It's just playing around with values until you find what feels good, and then once it works, you know, like stalling is a big thing you got to worry about if you're a pilot. Max thrust, fly straight up. Look at that. It's still climbing a little too much for my tastes. So maybe it really is just 40 and then reduce. Sorry about the playing with values, man. Like this is what I have to do when I'm not streaming. So like you're just seeing what part of the process is. Toying with stuff takes a lot more time than you'd think. Okay. So max throttle. We can climb, although that's pretty aggressive stalling. So maybe 50 is the play on desktop. And then once we get 30 gonna work, 40 was too much. So 50 seems like it could be our goal, like our Goldilocks zone here. Can we climb? Yeah, we can climb. We're still climbing. Once that number goes negative, that's when we've stalled. Okay. Oh, we're so close, but it's still climbing. It's actually staying completely still right now, which is not impossible. 47. Wouldn't it be weird if it was like a number this specific? That worked perfectly. If it is, we have to have a symbolic constant. Well, we're gonna have to do that anyway, but like, we can't forget what this number is. Okay, let's climb straight up. Is that a stall? It might be 45. It might be 45 because we've reached a point where we're actually 44. We're actually just staying still. We are very, 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 very close to being completely still in the air. Why odd? Why even? You suggested an odd number. Oh, 7. Oh, it's delayed. My bad. That's too aggressive. Even gonna work. Come on, let's go up. We're stalling too aggressively there. No shot. No shot that this is what works. Okay, we're flying. Come on, we're going at like an angle. We're still climbing. That's good. It's a little aggressive, but it works. We go straight up and we stall. That looks pretty good, actually. And this is kind of like an afterburner, you know? If we were to actually lower the throttle just a little bit, we can still climb. But like, we will stall very aggressively if we do that. Yeah, see? Look at that. And we lower the throttle and we're falling. And now we can... How we get out of the stall, we're going to have to fix that because it's not totally accurate. But we'll take this number. Hashtag define magic stall number. I broke every single rule of software engineering right there. We don't like magic numbers, and we don't like naming things magic number. But I don't care, at least right now. Okay, that seems to have worked. So stalling works. Now, what we need is when we stall, we want to face downwards. So the closer this number is to 0, the more downwards we want to face. So we're gonna, let's see, float fall face factor equals 1.0 minus math utils clamp applied force 0.0 1.0. So if we're flying at our full speed, we got no fall face factor. If we're stalled, we have full fall. Now the problem is this is not, we'll face way too far downwards. Maybe it's just how negative the number is. So what we could do is we could clamp this between negative 1.0 and 0.0. And now, and then we could just take the absolute value. Run ABS. And what that'll do is if we're going backwards, we'll fall. Oh yeah. Templates. And then if we're, let's see. Controls dot, wait a minute. And then transform dot rotation. We'll spherical lerp, so equals, we have the slurp method up here. What a weird name. All right. That, and we will lerp this to negative global up, so global down, and we'll do it based on fall face factor. Depending on how much we've stalled. This is not a float? Wait, hold on, what? Oh, this is not a quaternion. We want to rotate to face straight downwards. How do we initialize a quaternion with a vector? Is it Euler angles? How to initialize GLM quat with vector? Let's see. Rotation axis. Let's see. Angle axis. We don't want that. Euler angles. With a forward vector. Because we want it to just be pointing wherever we're. Forward direction, world up, orientation equals quad look at forward direction. Okay. That's totally something we can do. We can say GLM quad look at, and this will be negative global up, and we'll be looking at it from global up. And then this should let us, this should work. I'm saying naively. Okay. We're flying. That's good. Everything's working. Now we're going to stall. Okay. If we stall, that number should go negative. And we are not actually... There was some rotation there. Face fall factor. Let's make sure we're actually... like somewhat correct in our I mean, it would make sense because we're not actually getting anywhere close to -1. It should just be a very small number. So if we really quickly stall and we set it to, that's not enough. Not facing down. Yeah, it's not facing down. Quad look at. What? That's quad look at forward direction in the downward direction. Let's see. Down there. Target vector. Q down. Angle axis. What? Why are 90 degrees perpendicular? So we're rotating along the x-axis, so that makes sense, I guess. That makes sense. I wish there was a way we could just initialize it with a vector, because that seems very wrong. But we'll just say const GLM quat down quaternion equals that. And we do not need this to be initialized here. We'll initialize it somewhere else. We don't need to do that math every frame. Okay, let's stall this. Come on. There we go. Oh, that looks pretty good. And then if we get out of the stall, it looks pretty good. Good enough for government work. Now this needs to go somewhere else. We'll have to make this a constant GLM quat, and we will remove that. I think we can initialize this in the header. What editor am I using? I'm using Zed. I'm using the Zed editor. And I'm enjoying it a lot so far. It's written in Rust. It's basically VS Code, but in my opinion, actually good. I'm not a fan of VS Code. I've been a lifelong VS Code critic. Let's see. So we're trying to stall. We're at full throttle, and we're starting to kind of stall. Now, we should be facing down much, much sooner than that. So this actually should be like times 100. I think it's rotating fast. Let's see. So like we should be facing down, yeah, under like very, 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 very little stall speed. We should clamp that, shouldn't we? Math, utils, clamp, float. It's probably a little intense. Like if I'm being honest. Oh, we didn't specify we're clamping it. 0.0, 1.0. And then this way it should just always face down when we stall. And if that works, let's see. We're gonna fly straight up. And then we're gonna stall in a second. A little fast, but that works. I think 1 will probably be it. And then now we can start doing some graphics programming, some particles. I think they're going to be very, very, very basic, at least in the beginning. It's a little too easy to get out of a stall, I will admit. Like, yeah, we're going up, falling down, and then we also should take into account however fast we are falling. So like, if we're facing straight up, I'm not going to confuse this. I will fix that later. For now, that's good enough. All right. Particles time. Well, that should just be a type. You don't need that. Okay. Looking great. Thank you. All right. So, class particle system. And here's what we're going to need. For the particle system, it's going to use instanced rendering, and we're going to just have a batch of like a pool of transforms. So we're going to reuse transforms. I've never actually tried to implement them this way. Have I ever actually implemented particles now that I think about it? Yeah, don't touch it if it works. Yeah, don't touch it if it works. We don't want a vector of transforms. We do want a maximum number of transforms. So we should have a define max particle transforms. And we'll what? Who's calling me? Hold on. Yikes. Hold on. Stream. Okay. All right. So the max particles we should actually need is pretty... We're going to keep this low for now. We're going to say 25 particles. Yeah. And also the wingtips are not going to be particles. They're going to be a mesh that's created on the fly. Like a ribbon mesh. What's up, dude? All right. Let's see. GLM mat4. This will be transforms. And this will be a max particle transforms. It'll be just a const. Now, we want to change those. I'm trying to think. What if you Discord called me right now? If you Discord called me right now, it probably would go off. If I had to bet. You'll also accidentally dox yourself. So feel free. I'm not responsible. Okay. Let me think. When we initialize the particles, there should be like an update. So, and here's the thing: particle systems are going to have to figure out how to update their own particle instances. Like, we're not going to have particle force fields or anything like that. You're not going to be able to influence other particle systems. They're going to be kind of baked in a lot of ways. So this should actually probably just be like a pure virtual method. Update particles. Update transforms. Hey, I'll see you, man. I probably will be streaming tomorrow. And we also need a mesh. We'll have a void. We'll allow for a couple things. Virtual void load resources. Virtual void. What type of web game are you making? I'm making a web dogfighting game. So think of it like what's it? Think of it like 1v1.lol, Krunker.io, all of these fun games where you can like send your friend an invite code and just play against him. I want that to be like, I want that, but I want you to be able to do it with dogfighting, with fighter jets. I think that would be awesome. So might as well make it, you know? Update, and then we'll have, I think the draw method will not be virtual. It will be, we will implement this. How much is implemented in the header? Holy criminy. Yeah, this is unacceptable. I said I would change this off stream and then I proceeded to never do it. Void skeleton. Void skeleton. Update global bone transforms. There. And then we also should probably move all, we'll move this to the source file, get global bone transforms. And is this in bone? Actually, we don't even need this method. Nothing uses it anymore. It's an outdated. This is gonna be the next high school laptop game. I hope not to some degree, because, you know, that's like, kids need to pay attention in school. But I do know exactly what you're talking about. I would feel half guilty if that's actually what happened. And you can actually accelerate much faster if you're going down, which is accurate. Flying still feels pretty good. Can I climb to the top of this mountain? The sun looks surprisingly good for being such a simple thing. Can still fly up this mountain. It feels a little slow, I must admit. But I think in this case, it's okay. Worst case, I mean, realistically, it's kind of hard to fly a plane straight up, you know? Or upwards. And that's still pretty good. Yeah, that's still pretty good. All right, so that's pretty good. What? Particles. We need to implement the basic particle drawing system. Draw. And we also need an unload resources method. They'll handle their own. Virtual void unload resources. Which model are you using to render the game in C++? I'm using OpenGL, so it's kind of everything's manual. Pretty much writing my own game engine. T I equals 0. I is less than max particles transformed by I plus. Sometimes Zed's auto like complete is not my favorite, but it's just too fast to ignore, you know. And then first thing we're gonna want is we're just going, well, yeah, we'll need our own particle shader. Particles. And then if you want to make a particle system, you're gonna have to inherit from particles, which means we'll probably need special kinds of particles. The first particle system we're gonna test is gonna be the trail of like smoke from behind the jet. Aircraft wake particles. Aircraft exhaust. I think I spelled that right. Particle system. Public particle system. And then we're gonna need a couple things. We're gonna need a void load resources, override, void initialize, override void update, override void unload resources, override. And then the other thing we're gonna need, also these should be protected now that I'm thinking about it. Yeah, you should not be able to just alter that. That should be protected. Only the system itself can do that. And then everything else will be accessible there. We'll need a mesh. Mesh. We'll need a shader. And then, should we have a file that dictates particle systems? Like a mesh? No, we don't need that. But we do actually now have terrains implemented through files. You'll see what the terrain... So this is the terrain file right now. It's just... it points to a shader and a height map. Pretty straightforward. But I plan to have... I don't want to say I plan to have anything, because that feels like I'm promising something, and I then have to deliver. But I would like to, in the future, have a... let me turn it down. I would like to have some sort of map editor. I mean, the maps are going to be very simple, so it shouldn't be impossible to have an editor. It might be desktop only. I don't know. I really don't know. But then we'll have to think about, like, how do we host maps? Would there be like a server where you could download maps? This quickly could get completely out of hand. Okay, so the way that drawing is going to work here is we should have, yes, we need a method to begin drawing instanced meshes. Hi, bro. I'm back to watch the stream. Hey, man. What's up? We need static void begin draw mesh instanced. And this should take in a mesh, a shader, a camera, and instead of that, it will take transform pointer transforms list transforms, and it will take an size t num transforms, and then we'll have a static void end draw mesh instanced mesh. Wait a minute, the actual draw call is happening. I did a lot of instance render. Have I gotten collisions in the engines? No. Those won't be for a little bit, because the collision's easy to implement. But, like, if you collide and blow up, okay, we now have to make particle systems for the plane exploding. We now have to make particle systems for... No, we now have to, like, have the user go to a menu or to, like, somewhere else or respawn. Like, that's the frustrating part. So, no, not yet collisions. Once we have a life and death cycle, collisions will come. Bro, I've tried a lot of time learning coding these bugs, but it didn't work every time. Give me the best sources to make a start. I never learned from like a textbook or sitting down and actually studying it. I just thought, I want to make a video game my friends can play, and I learned whatever the bare minimum to make that happen was. And you can pick up most of the details along the way. Yeah, my advice, find a project you actually want to build, not one that you like, I feel like I should build this thing because it will teach me. No, like find something you actually want to build, you want to make. Right now you're in the phase where it's kind of fun, and build it. Look up whatever resources you need to build it. I would avoid copying and pasting copious amounts of code, but I won't pretend I didn't do that in the beginning. I still do that now every now and then, but like, it really comes down to just make something you want to make. Don't think about the learning process. You'll learn like almost by accident. I learned OpenGL essentially by accident by learning lightweight Java game library. I had no idea what OpenGL was. I thought it was lightweight Java game library, but then I realized I was using OpenGL, and I realized I had accidentally learned it in Java. Let's see, graphics, draw instanced. Yeah. We don't want shadow maps. Draw instanced objects. How did we do this? I believe I used a transform buffer in this engine. Indices.size, transforms.size. Can you add seismic charges as an Easter egg? Once we have weapons, like, actually in the game, yeah, it'd be awesome. We still are going to need that num transforms. Num transforms. Let's see. We don't have any definition for that, so let's here void graphics backend begin draw mesh instanced, and then we'll void graphics backend and draw mesh instanced. But yeah, seismic charges would be awesome. And if I can make this data-driven like design thing work well, maybe I can have some sort of like I don't know, maybe it'll be easy to make that kind of stuff. I don't know. I can't think I would add bombs off the bat though into this, because like that needs ground units. Ground, that's a whole thing right there. So I don't, we'll see. We'll see. Begin draw mesh instanced and draw mesh instanced. What was it? It's pretty similar to the just standard begin draw mesh and end draw mesh methods. I don't want to have to do the bad method to upload an array of transforms, but in the beginning we will do it. Okay, but we will do view transforms. We will do this. Okay, so we have our mesh, our shader, our camera, transforms. So what we're gonna do here is we're gonna say for size t I equals 0, I is less than num transforms I plus plus. And then in here we're gonna say transforms I, and that's gonna be u view transforms plus I plus that. And that should work. Do we need to upload this to? Might as well try. Make sure, might as well just not break anything. I to what was it? To string, I think. std to string I, because we can't just do that. And then we'll just boom, boom, transforms I. That's what we need there. Okay. And then this is GL draw draw elements instanced. And then what were the arguments? Triangles, mesh index count, GL unsigned int 0, and then we also just have to add how many times we're going to draw it, which is max no transforms. Although that's a good point. We're always going to have to draw the maximum number of particles with how this is currently set up. Like, we'll always have to do that. Which means we probably should specify how many no, but these are allocated on compile time, so it's okay. We'll fix that later. We need this particles shader. It's pretty much just going to be the flat shader, but instead of this, we're going to have a define max particles, max particle number. What was it? What did I call it? Types max particle transforms. Max particle transform. We'll call it max particles, and we'll 25, and then max particles, and then we'll take that there, and if I remember correctly, there's a way we can reference which instance element. GL instance. Let's see. Instanced rendering OpenGL. There's a way we can reference which instance we're on. What was it? It was in the fragment shader. We'll have to do this through. There's some serious optimizations we're gonna have to do, but that's okay. Amount. That's not it. That's not it. Okay, where's the? Gosh darn it! Where is the instance ID? There's a way that we can know which instance we're on. Get access to instance. Hey, what's up, dude? ID in OpenGL. Get access to instance. Yeah, GL instance ID. That's what it was. GL instance ID. And we'll take that. Transforms GL instance ID. That should give us off the bat something that works. Although that does mean we're always going to use the same shader. That's okay. I'm not too concerned about that. Another program. Let's see. With Mr. Azozan. Is that the Soding Daily guy? I actually think I might know who you're talking about. Load. What? Why is it saying it's not exhaust particle system load resources? That should be a load. Why is it not automatically filling that? Beans on a microphone. What are you saying? These are all override methods. Why? Okay, maybe this is just like it Zed being slow to update. Load resources. Unless there's something sinister going on. Let me try to compile this. We're not going to get definitions for everything else. What? Cannot convert. Are we doing something wrong here? Transforms. Oh. Yeah, 4. And I personally like putting it like that. If there is a right or a wrong way to do things. We also didn't update the header. GLM map 4 transforms. There we go. Chili and a microphone. Chili mic. Oh my gosh, dude. I'll give points for creativity on that one. We don't need this. That should just be the transform. Where are we missing a semicolon? Aircraft.hpp. Where? Yeah. That's probably why we had this problem. Okay. Void aircraft. Exhaust particle system. It's just not working. Alright. What's up, dude? So it compiles. Yep, it's just Zed being a little bit behind the... Let's see. Update. And then we'll have our unload resources. Unload resources. I'm not using VS Code. I'm using Rust, actually. Gosh, I'm using Zed. It's a different IDE. Very similar to VS Code in like terms that it's kind of versatile and just does every language, but way faster. And I like it a lot. A little new. Some plugins are not quite there yet, but I like it a lot. Mesh equals graphics backend, create. We'll just use a cube for now, and then shader will be equals graphics backend, create shader. Resources slash shaders slash particles. .glsl. Okay, we've got our shader. Initialize, there's nothing we really need to do there. So in all honesty, we probably can just get rid of that. And then update. We'll need that later. And we should also graphics backend destroy mesh. Graphics backend. Next cool high school game. You're the second guy to say that. I hope people play it, but I hope the kids don't skip out on class. That's not a good thing. I'm making this not out of that. I'm making this because I think the barrier to entry with games like this is much lower than other games, you know? Like, I'm not competing with a bunch of Steam titles. I'm competing with, as of now, I want to say literally no one. If we fall like this, oh, there's a thing. The throttle being set to 0 and falling because of that doesn't make us... I'm going to get sidetracked if I fix that. I'll remember that later. Let's see. And then we should just say graphics backend begin. We need this implemented in types, don't we? Yeah. Do we need that, actually? It's begin graphics backend begin draw mesh instanced. Mesh shader. We'll get our active camera, which would be scene manager. Wait a minute. Is the scene manager something we can... Can we access the scene manager? Scene manager, active camera. I feel like this is not going to... Like, I'm not going to be able to do this. I think there's a reason. Gameplay, scene manager.hpp. What? Why is it not auto-completing? Scene manager. Was it active camera? I think that's what it was. And then we'll just pass in our transforms. And then we'll pass in max particle transforms for that. And then graphics backend end draw mesh instanced. Mesh max particle transforms. I wonder if... I doubt this will work. Yeah, there's something wrong. Oh. Scene manager. I keep forgetting I put that in a separate file. Please work. Oh, it worked. Yeah, man. It would... I wish I started making this game a little... You know, I've had this idea for... I think a year or two, actually, at this point. I tried to make it in Godot. I really failed royally. It actually looked significantly worse in a actual game engine than it does right now in my own engine. Not to say Godot had bad graphics. It was entirely my fault. But let's see. What happened to War Games? I still have it. War Games was another game I worked on in Godot. I got bored because I was working in a game, because I was working in a game engine and I wasn't writing as much code. I was more working on art. I hate making art. And my spaghetti code came back to bite me. This was a while ago. If I think I know the game you're talking about, this was a long time ago. I was not nearly as good at this stuff as I am now. That implying that I'm good at this stuff. But like, it was bad. It was really bad. What am I... Yeah, I don't want this STD cout thing. Cout. We don't need that. Yeah, let's see. Okay, so here's the thing. No particles seem to be being drawn, but that could be because... here's the issue. The particles are being drawn... Wait a minute. Hold on. We have no transforms being populated here. Let's see. Like, all of our transforms are not working. Let me think about this. Position. Let's just see if we can get something on the screen before we worry about anything else. Wait, did something just crash? Was there a crash of some form? No crashes. Why is pressing tab rotating the plane? What the... Oh! Tab is how you free look. I forgot I had that. GLFW key tab. Extra rotation should not be applied. I have my practice exam tomorrow. Looks interesting to watch. Don't let me get in the way, dude. Extra rotation equals angle axis clamp roll magnifier. Well, rather this should be what we do. UI difference should be that. And then we should not... Let me think. It should persist between frames. Yeah, that's what we need. The UI difference should persist. We don't need that to be gosh, there's so many random values that shouldn't be here, but you know what? If it ain't broke, don't fix it. Come on. Okay. If we press tab, not exactly what I was hoping for. Wait, that's actually not a problem. But when we press tab, we should just not be like looking towards our target rotation should not be being changed. Where are we editing the target rotation? Target rotation. GLM quaternion. We don't need that. Camera forward. Yeah, this should be, if that's not the case. I hope this doesn't break things. Let's see. We're flying. Hold down tab. Yeah, we can free look now. It seems to be working. Actually looks very cool. And then we release tab, and if we hold down tab, we just keep going straight. It's kind of cool. Obviously, it shouldn't snap back like that, but it's okay. We can fix that. That's not bad. I'm actually intrigued. Okay, let me think. We need to get back to drawing these particles. What is going on? Why is it that begin draw mesh instance? Are we doing something wrong here? And that's correct. Projection, transforms, fragment, albedo, drawing num transforms. There shouldn't be anything going on. Oh. I think I know what's wrong. I think I do know what's wrong. If we have backface culling turned on, so right now the particles are being drawn directly on top of our camera. Yeah, it should return to normal. I know. I can change all of that, but that's stuff I'm going to work on later. I think the problem here is that set backface culling false, and then we'll set it to true again after this. True. All right. Come on. Draw. No, that definitely didn't work. So what's going on here? Is it because we're setting it to be cubes? Create quad. Let's try that. Will this change anything? Will it not? Are we just doomed to fail? Particles, world transform. That shouldn't. Projection and transformation should not be doing anything right now. Yet they are. Why is that? Why is it that is it the color? No. I mean, I do want this to just be a white cube for now. Look more cool. Yeah, exactly. You know, you'll be able to look over your shoulder and see where people are. Like if I pull up and then I look back, that we encountered a bug, people. Let's see. We're flying upwards, or not straight up, but we're now angled, and I look back. Yeah, I can see there's someone behind me, and then I can, you know, try to get them. That'd be cool. There's obviously going to be a lot of bugs with that stalling. I might actually one day go back and completely rewrite that. It seems very prone to error, at least right now. But let's see. So the particles should be... We don't need this extract rotation in every single file. I should add GLSL includes at some point. What's going on here? Let's try to just draw it normal. And see if it's how we're drawing it. No, it's nothing to do with how we're drawing it. End draw mesh instance. Begin draw mesh instance. Let's try drawing it with just something we know works. Let's see. Maybe begin draw mesh. It needs a transform. We're not using any transforms. So we could just say transform. We could just pass in a new transform. Yeah, we can't do that. Transform t equals that. So it's nothing wrong with our shader. It's everything to do with something else. What is going on? I'm so stupid. I'm so stupid. I'm a fool. I actually am not even creating this thing. I don't know why I even thought I'm stupid. I can't believe I just did that. You know, that's fine. We'll have an aircraft exhaust particle system, exhaust particles. This should be defined up here. It doesn't depend on the aircraft at all, I don't believe. At least right now it doesn't. It will probably. And then on the construct, actually we can just aircraft exhaust particle system. Yeah, that should work off the bat. And then load resources, we can say exhaust what the, why is my auto complete just not giving me anything? Load resources, and then that update, that unload resources, and then there's a draw. No comment on that, okay? Y'all aren't writing the code. I am. So it's my, yeah, whatever. Sources. All right. That's frustrating, but that's okay. Dot initialize. And then apply control surfaces. Update. We'll update this at the very end. Dot update. And then we'll draw this at the end. Draw. And then we'll unload resources. And if we did everything right, which is unlikely, yeah. Declared private. Wait a minute. I didn't declare those private, did I? Is it because in our actual implementation, we just didn't declare it public? Yeah. That's okay. Minor inconvenience. Let's see. And we got a build error. What happened? VTable for particle system. What? Where have I seen that error before? I'm also impressed you're not using AI, using documentation. I'm trying to. I think, yes, the one thing I did use AI for this project was when I had that floating point precision error. I was like, dude, what is even causing this? So I did have to help. I used some AI to solve that bug, admittedly. But yeah, I do try to avoid using AI. I think fundamentally it makes you a worse developer, if that makes sense. I think that's the issue. What is it with this VTable? I know what I've seen this error before, and I think it has something to do with initializing this. Maybe we should do it in the load resources. Load resources, we will create it. Exhaust particles equals aircraft exhaust particle system. Yeah, sometimes it's fine. I really try to avoid it if I really, because I do want to understand this stuff. Undefined reference VTO for particle system. There's something here. I know what, I've seen this before. I really do know exactly what's. Is it because that could be it? It could be because you can't just initialize. That's it. Let's not forget the colors. When are we? And the colors. When are we getting an IRL stream? What do you mean an IRL stream? I don't even know what that is. You have to explain that to me. We have a bug. Okay, I need to actually figure out what this is. What does that mean? It's a linker error. I know that. Virtual definition. Oh, I know. I have seen this error before. I know exactly what it is. You have to do that. I think people don't even try and just copy paste. Now, yeah, that's the problem. It's really easy to. And you don't, you can feel like you're learning from using AI, but like, I think you just feel like you are. If someone was to ask you to reproduce that, whatever the AI taught you, that works. That's good. We did it right. It's working. If someone asked you to just, make it from scratch, no AI, I feel like anything that I've learned using AI, I couldn't do. I also know that, like, you're streaming like a day in the life, walk around your phone, stream the entire day. I thought about doing that last semester, actually. I tried that. Is something broken? Something's wrong. No, it looks like it loaded everything, right? So, let's see. This is going to cause backface culling, so we're not going to see the quad. It's all just going to be invisible, I think. Yeah, that makes sense. The cube is right now in front of our, like, surrounding our camera. I might do a day in the life at some point. I don't know. My life in college is really boring. It's way more interesting. Well, that's not necessarily true. RTC can get really interesting sometimes, but it's not the YouTuber, like, get after it grind that you like can really film, I guess. That like y'all want to see me wake up at 5 a.m. and then go to PT in the morning and then drive back and then go to lecture and then go to study, and like it just, yeah, it's not the most entertaining thing. But I guess maybe one day I will. It's also pretty hard, honestly, to film all of that. I wonder if this will work. We have no idea if it worked because it's at World Center. And we also know that this entire... we do need the initialize method, actually. Yeah, we need the initialize method because we need to get all of those transforms initialized to the GLM identity. Let's see, update for size t I equals 0. I is less than max particles transform I plus I plus what was it? Transforms I equals GLM identity. GLM map4. Map4. Now that should make it. The view matrix is gonna cause this to not be in front of the cam. Wait. Undefined reference to particle system dot initial. Oh, because I did this in the update method. That would have been bad, actually. If I kept that. Aircraft exhaust. Void aircraft exhaust particle system. Initialize. Yeah, let's see. The only thing I actually regularly used AI for was, like, I would make myself practice tests for school. I think that's the only thing I've ever actually consistently used AI for. Everything else has just been like, this is... And even that was kind of, like, frustrating, because it would just get stuff wrong, and I'd have to explain, like, the problem you gave me is unsolvable. Like, no, it's not unsolvable. You're just stupid. And they're like, no, it's an unsolvable problem. And it would be unsolvable. But you know what? I was really good at taking calculus tests, because when the problems on the test weren't unsolvable, wow, it was crazy. But yeah, I think actually if we just get rid of temporarily in here, if we got rid of this, we just boom. That should do nothing. We still have the backface thing going. So if we add the backface culling back, that's a bug. No, it's not a bug. What? I've seen that bug before where everything goes gray. I don't know what causes it, but whatever it is, it's kind of frustrating. Okay. So when we add the view matrix, nothing changes. So we remove the view matrix. Let me make sure that built. All right. I don't think we updated our shader. No, we did. It just broke. That's all. That's not a big deal. We can keep it like this for now, and then in the shader, we should have this that we can also use, and then we'll try that. Are we inside of the cube? Is that what this is? Is the cube for some reason gray? It shouldn't be. That would make very little sense. Is the cube gray? Man, that's frustrating. Maybe what we do. Maybe what we do is we just set it every frame to be the plane position for size t I equals 0, I is less than max particle system transform I plus transforms I equals what? We want control over all of the scale, rotation, all that stuff. What was the... There's a construct transform method. Let's see, transform. I have something somewhere that takes care of all of that stuff. I think it's in here. Let's see. Get matrix. Yeah, this is what it was. So if we can just take that. If we can go down. There we go. Translation equals translate. Let's see. Yeah, there's an integration problem. I replied the wrong question. Correct this. That's why I only use it for explaining topics. Yeah, I honestly just learned more from let's see, text transforms I. That's what we need. We need to. Well, no, we do want this to just be the identity every time. Scale, translation, return translations times scale. We don't need that. We can just copy that, put that there, remove that line. Boom. We don't have a position. We can get aircraft position, which we actually need access to now that I'm thinking about it. We need a public constructor, and we need to have a pointer to the aircraft. We can't have a pointer to the aircraft. Is there maybe a pointer to the position? glm vec3 pointer aircraft position. We only need the position, and then we can just take in a glm vec. Wait a minute. I think these are hosted on the what? On the heap. I feel like there's some dynamic memory stuff going on with these. This may not work. This may actually be a really terrible idea. Aircraft position, and we'll just take aircraft position. Aircraft position. We'll take that, and then we'll go back up here. Where do we create the air? Let's see, exhaust. Oh my gosh, yeah. And then we'll just take aircraft position. Transform that position. And we'll give it that pointer. I hope this works. I feel like it won't. I'm pretty sure this is a bad idea. We're gonna do it anyway. Aircraft resource path. What is going on here? Are we including something we shouldn't? Is there something going on here? I just know that we need access to that aircraft position somehow. And I know that we had it here for the aircraft UI. I think we need something similar for the particle systems as well. We don't want to handle that through the scene now, do we? Do we want a list of particle systems in the scene that we have to update? I don't think we want that. This objectively does now have to go below here, and we shouldn't have access to the... But the aircraft should have control over its own particle system. Yeah, that's something that should happen. So here's what we're going to do. In the particle system here, we're going to have a vec3 aircraft position. But making a note from scratch is so cool. Yeah, it is pretty cool. Let's see, void set. And we're just, this is not best practice. We're just going to set this every frame. Before we update, we're going to say exhaust particles. Oh my gosh. Exhaust particles. Hey, Formula Center. I see that you're playing. I see a set of Corsa getting booted up. Exhaust particles dot aircraft position equals transform dot position. I think that should work. Of course, that's, you know, we have a rotation that doesn't exist, and that's okay. I fully expected that. Rotation. We don't need rotation. We don't need scale. We just need this for now. We can get all that extra functionality later. In fact, we actually don't even need to temporarily store this. And this will be aircraft position. No, aircraft position. I failed. Why did it fail? Exactly. I'm a D-playing set, of course. I know you are. Oh, I didn't change this back. We need to change something back. Yeah, we don't need that anymore. This should now give us something to see on the plane at all times. Of course, it's not on the plane at all times. Our frame rate hasn't changed, which is good. Could it be that maybe, again, let's just do this test and draw mesh. Transforms 0. We're just going to give it our base transform. Like the, actually, wait. Transform t equals transform t dot, I don't think that's the way we want to do this. We don't. That's really annoying, actually. We'll just transform t dot, no. Gosh darn it. We don't have access to the data we need for this. So what if in the draw mesh instance method instead? Hear me out. What do we do? This is a little annoying, actually. I don't even... Transforms, view transforms, max particles. I think we have 20 particles, that's correct. We're doing everything right, I think. Particles, exhaust particles dot update. Are we drawing? Yeah, we're drawing them. So why is it that our exhaust particles don't want to work? This should be moved to wherever our aircraft's global position is, right? Because transform dot position right before aircraft update. Yeah, aircraft position. What is going on? Why would it not draw? Maybe the box is too small. That could be it, actually. It could be that this box is like phased inside the plane. Copy that, and we'll make it just a much bigger. How do we do that? Times that. And the scale will be GLM vec3 10.0. We'll make it 15. Yeah, we'll really push the boundaries on this. Yet that didn't. Oh, whoa. Did you see that? We went a little too big, but the particles are there. Instance rendering. may in fact be working. There's some like area in between where our camera is and where our plane is. Why was 15 working? What was so special about a scale of 15? And why was it only working when we zoomed in? Yeah, what is that? Let's see. When we rotate, it's going the other direction. A little confused what's going on here. I won't kid you. What happens if we make it bigger? If we make it bigger, does that change anything? No, it disappears. So there's a brief period where this thing works. Unless... I have an idea. Very stupid idea, but an idea. For some reason, this cube's gray. I also don't know why this cube's gray. That's why it's gray. That works. We need this thing to just be kind of like in front of our camera. We need to know that it's there and that it's being drawn. And the way we're going to do that is by going in here and moving it just in front of us. And then we will scale it up. Although maybe we don't need to scale it up. Maybe we just need to leave it at 1 for now. If we leave it at 1, notice that my viewership drops dramatically when I'm working on the boring behind the scenes stuff. I mean, I will give you this. It is a little boring. We're probably scaling this wrong, honestly. Probably shouldn't just do rotation and scale only. Maybe we move it the other direction, perhaps. Let's see. What on earth? Why'd you turn off a set of chords and then turn? Not boring? Thank you. I don't think it's boring. I enjoy it. I enjoy it very greatly. Very much. And for me, this is the most exciting thing that you could do with your time. I actually do really find this so much fun. Like, cannot describe the funness that I am experiencing. Move this forward like 4, and then scale 3, 1.0, and then rotation is GLM identity, GLM quat, and then we need to go up to the very top. I use Content Manager, so every time I load into something, a new track. Yeah, that's a good point, actually. I've noticed that every time. Yeah, that makes a lot of sense, actually. Don't worry, the pop-ups on the bottom right of my screen is blocked by my camera, so you're not getting doxxed every time you boot up this game. Scale. Is it called SCA in this thing? Wouldn't that be funny if it just was randomly called that? Well, it again appears to be off screen somewhere. What if I, once again, remove backface culling? Man. Oh, now it just doesn't actually cover the camera at all. Oh, it's because we're still using this. Well, that's weird. That shouldn't be what's going on. Translation. Should just not be moving anywhere. It should be completely still, we should have our camera covered. How can we get back to that point when our camera was just completely covered? This is so stinking difficult. Are we calling all of these methods? Are we calling update? Aircraft position equals transform.position. We're scaling everything right. From everything I can tell, everything here is being done correctly, unless I... Like, this will verify that the cube exists. Yeah, it's white. Totally exists. She's real. She exists. Okay. That didn't update the shader. Dude, I use Git. I love Git. I would never want to use anything besides Git. Yeah, for me, it works, you know? I understand it. Might I ask, what is your motivation to use something that's not Git? Like, why? You know? Why reinvent the wheel? Unless that's a project of yours or something. What the heck? Why is it that this thing goes invisible when I move it anywhere? Like, always. It's not invisible now, that's for sure. Times scale. This should shrink it. You should be able to actually kind of see. Yeah. Okay, so the cube's there. And then if we go and we take our view transforms, this will make it go away, yes. But it is being drawn somewhere. And that's what's important. Okay, so it's being drawn somewhere. We'll move it to... We'll keep it at 0, 0. Wouldn't that mean it's... Wait a minute. If this worked, this thing should be being drawn at position 0, 0. How do you add audio engine? I'm gonna have to do that for the first time, actually. When I will let you know how I do it. It's probably just gonna be loading in like an audio file and then just playing it somehow. But yeah, I've never actually done that. I've never done an audio engine before. I'm excited about the challenge because it probably will be a challenge. I'm gonna have to make all the sounds. That's what I'm not excited about. I hate making assets. Like, I'm not excited. That does not make me get me excited. Hold on. We are gonna spawn our plane at 0, 0 actually. Position.y. And we're gonna spawn at 0, 0, and the cube should be right here. Wherever we spawned, we should be right on top of where this cube is. But it's not right here. Why is that? Is it that maybe this get view matrix? Let's see. GLM map4 camera view equals. All right. And then camera view. And we'll also say std cout glm to string camera view. std and l. Okay, so that's definitely working. What could be the issue? Because clearly something's wrong with the camera view, right? If we go into particles, this particle system is clearly going to be one of the more frustrating. In the draw function, you are using draw elements instead of draw element instanced. Are you serious? Oh, I didn't switch that back. Thank you so much. I was... thank you. That was for debugging purposes earlier. but it makes total sense if that's the problem. Still invisible. Still completely invisible. Let's see, types. Yeah, we still have the culling off. Interesting. Let me just make sure our transforms are correct. Yeah, it should just be at 0, 0 right now. So if we're spawning this particle in, it's spawning in at position 0, 0. And we're setting it to that every single frame, right? Like we spawn in all the we initialize all the particles. We actually don't need to do that, right? We have to initialize them. We'll leave that as is. Max particles, translation. We're translating the should we be translating the identity matrix? I feel like that's what we should be doing. Still no cube. Why? Is it? No, the culling's turned off, so it shouldn't be gone anywhere. Man, if only I had RenderDoc installed right about now. Skull, translation, scale. Okay, we're gonna get RenderDoc. I'm gonna figure out what is going on. This tool is amazing. I haven't installed it on my new hard drive yet. But RenderDoc is a must-have for anybody and everybody who does any sort of computer graphics work. Is Mike? Oh, shoot. Oh, we're good. RenderDoc should be working now. It lets you debug graphics really, really, really well. And the way we need to do this, we need to go documents. What is it? It's in dev. Dev, WebDog Fight. Build desktop, WebDog Fight. Launch. Allow. We want some. Oh, it has control of the. Uh-oh. Why is this not? Okay, whatever. We'll queue capture on close. We need to rebuild this because. Let's see. Yeah, we do need the view transforms thing. Launch. This should just. Why is it that this is not wanting me to? Yeah, loading capture. Okay. What is going on? Wait, what? Is this not the right application? We set this up right? Let's see. Vendor. Are we running the? What the? This is our build folder, right? I guess not. What are we? How are we running this? Task. Run desktop. Let me build desktop webdogfight.exe. So why is this not? What the? Wait a minute. There we go. We don't want to save that capture. We're just capturing the first frame. That was a problem. So it's queued the capture. I don't know why it's still white. It's probably a bad sign if I'm being honest. That looks maybe a little like there's a little more going on here. Okay. So, RenderDoc. Let's see. Draw elements instanced. Let's see. Mesh viewer. Is there anything wrong with? Well, it should be letting us view the mesh output, but maybe that's the problem. Like, which mesh are we looking at? Draw elements, draw elements. So the mesh viewer just is not showing us. Ah, there we go. So that's our mesh. I want solid color. No. Flat shaded, maybe. I don't know why it's not showing us vertex shader out. I want vertex shader in. Yeah, this is our plane mesh. Under the hood. So let's see draw instance. Okay, so we are dealing with a cube. And then our vertex shader out is just a cube covering the entire screen. Which is interesting because I don't think that's what we see on this end. Yeah, that's not what we see on this end. On this end, we see nothing. It's a puzzling bug. Translate scale. What on earth is going on here? We're getting a different result when we run this in RenderDoc than just running this normally. That's okay, so that's correct. Although that's not our... Oh, I see. I know exactly what's going on. Yeah, now we run it in RenderDoc and everything works accordingly. And the reason for that is because... Okay, we go back to RenderDoc. Let's see. Draw elements, draw elements. It's this draw elements instance method. We're drawing it before we're drawing the terrain, actually. So pipeline state, vertex shader, mesh viewer, vertex shader in, vertex shader out. There's there's something over to our left. What on earth is going? Wait. Should we just not draw the entire terrain and see if it's easier to find this cube? We actually have to find a cube. I never thought I was gonna have to do that. Let's see. Let's scale it by 100. If that's the problem. If our problem is just finding this thing, we've lost our cube. I really should have a way for the camera to just free look. Whoa, wait, that was white. Did you see that? I saw something. Okay, are we inside of the cube? Is that the problem? Maybe it's too big. Let's see. Go here. Interesting. Very interesting. Is the cube bigger than we thought? Maybe it needs to be smaller. Like, what a weird issue to have. Like, in a particle system, we legit just can't find the cube. And it should be at the world origin, but it's not. Maybe it's in our translation. It's probably something to do with how we're calculating all of this. There should be scale. I'm actually disappointed that I didn't. No, it is sky because the scale is something else. So the position is 0. The scale is 1. And the rotation is just identity. So we could types glm to map for rotation. All right. Which is just glm identity glm quat. Our scale is just that. Okay. Position 0 scale. Maybe we just have to have rotation. Maybe the fact that we don't have rotation involved is just breaking everything. What on earth, dude? Let's just... I'm not mad. I'm just very, very frustrated. Like, extremely frustrated. We are going to do... We're just debugging. This is just part of the process. This may be the most boring thing ever, but it's part of the process. We're just going to draw it normal. And then in the particles shader, we're just going to get 0 for both of them. And this should just draw a cube. Wait a minute. Wait. Maybe there's something wrong with our transforms? That could be it. We could be passing in... Wait a minute. Geom2 string transforms I. Maybe that's where the discrepancy is. Maybe it's like something wrong with the data we're passing in. What an interesting... Hold on. Met 4x4. So these are all identity matrices. Which makes sense because we're scaling it by... We're not moving it. We're not rotating it. We're not scaling it. So these are all correct. This is fine. Camera view is fine. So maybe it's the camera view. But the camera view wasn't doing anything last time. So why is it doing something this time? Is it the inverse camera view matrix or something that we should be doing? Projection. Oh, man. Well, ironically, the stream also has to end at some point because I also have to be somewhere. Thank goodness. This is like sweet release at this point. Oh my gosh. I mean, what the... I don't know what is going on. I don't know why this isn't working. I'm deeply disappointed that it's not working. But in my disappointment, I will... Here, let's see, position.y. I will fly around my plane in my disappointment. And we're going to do it in the web as well, because I need to make sure that this didn't break anything on the web. It seems to work all right on the desktop, but sometimes, like, the web's a little finicky. I'm telling you, man, these particles are going to be worth it once they're in the engine, but they're going to be a pain in the butt to get in the engine. Okay. Let's see. Let's go into the terrain a little bit and just see if we can find anything down here. Maybe it's the mesh, you know? Create cube. Cube. It could be cube. We want, maybe it's loader. Loader, load, mesh from GLTF, resources slash meshes, sphere, GLTF. Maybe this will give us some luck. I highly doubt it. But you never know. We're also super high up again, which is going to make it impossible to see if we actually fixed anything. Let's see. Could it be that our position that X is somewhere? Let's see, transform. Are we starting off at the origin? This is all assuming that we're at the origin at the beginning. Yeah, we should be at the origin. I don't know why. Transform that position. Yeah, that should work. So let's... Sphere is still not here. Man. what a pain in the butt, man. What a disappointing situation. Maybe we could do it. Maybe we can solve the problem of, okay. We're going to do like a 2-second rewrite. I have an idea. I feel like there's something going, like, sometimes if I'm really stumped, I rewrite something kind of from the ground up or just completely differently. Transform particle transforms. Let's see, transforms. All right, and then our draw method needs to change to take in a begin draw meshes instance. It will take in std vector to transforms, and we'll take in a reference to that. We don't need this anymore. We'll go here. Oh my gosh. Instanced. Yeah, we'll take this, put that there. Okay, so now we have access to our transforms list. We should be able to just iterate through it going transforms.size. We should say transforms I.get matrix, right? Actually, glm mat4 matrix transform equals transforms I.get matrix. We'll just call it transform matrix. And then throw that there, throw that there. Build. Probably going to get some errors somewhere. Let's see. Times scale. Yeah, we don't need any of that. So in the aircraft position here, exhaust particles, draw, all of that stuff. Yeah, okay. So when we initialize, this is not what we should. We don't actually need to initialize them. Transforms.size, and then we could hypothetically just leave it empty because the transforms handle their own initialization pretty well. In types, we're drawing wrong there. Build sus. We also aren't calling GeoDraw meshes instanced. That's another thing we need to do. I think it was above this. You draw elements instanced. Yeah, we'll take that, and this will be. We don't need num transforms. We just need. Well, we could do that. Num transforms, and because no, wait a minute. So this won't work either because let's see, std vector transforms dot size. Okay, perfect. And then if we go back to our graphics backend, we do not want that. We want this again. And then in our types, we'll have to transforms. Although thinking about it this way, we're going to have to initialize these. So for size t I equals 0, I is less than max, particle transforms I plus, and then we're going to have to set each transform equals transform. We're going to have to initialize them all like that. Wait a minute. That's going to break. That's going to get a heat because we need a pushback. So push back transform. Think we can do it that way? We might not be able to do it that way. Nope, it worked. Let's see if this works. Still doesn't work. But I think we're okay. We can test if this is working by doing this and just seeing if our transformation data is still being updated. Because if this works, okay, so we know it's not the transforms. We know for a fact that what is going on here is something with the fact that we're doing the view transform. Ooh. World nature, world position. Let's see if that's changing anything by chance. Oh, there's the sphere. We did it. We did it. Now that I'm thinking about it, however, that did not seem to be moving the way a transform T a sphere should be moving. T.scale equals glm vec3. Make it 10 times bigger. And that would be T. And then, do you have to do the same thing today as yesterday? I don't know. I'm assuming so. Oh yeah, look at that. And it should also work with the cube. Graphics backend, create cube. And now if we've got cubes working, we've got everything working. Yep, cubes work. All right. Particles. We'll get the color part of this working as well in a moment. But that means we can say for size t I equals 0, I is less than max. Let's see, transforms.size I plus plus. And then we can say transforms I dot position equals air position. This should now have a cube constantly on top of where the plane is. Yep. It works. Let me just make sure I don't have somewhere I need to be. That works though. That actually works. Frame rate's doing all right. I know. It only took so long. I mean, okay. So how are we gonna now, we shouldn't be using this vector. I'm gonna be honest. This is not the way to do things. So I'm now going to revert that. Let's just, we'll still do this. We'll have a pool of transforms. That's what we're gonna do. Begin drop meshes instance. Yeah. I know, dude. I know. Transforms. Let's see. Unsigned. Unsigned. Well, wait. We shouldn't have to specify any of that stuff. Transforms here. Transforms. We don't even need that. This actually simplifies our code a little bit. Now that I'm thinking about it. And draw mesh. We can just say max particle transforms. In here, we can just say max particle transforms. And we can just sub this out for a transform pointer transforms. And now, of course, the aircraft is going to have some problems. Like, we don't have the pushback method anymore. Transforms dot size isn't going to work. But this seems to all be issues with the aircraft method and nothing else, which means, let's see. Oh, we didn't change that in there. Did we? No, we did. All right, so aircraft method. There's no such thing as pushback. It's just transforms I equals transform. And it's a copy method. I is less than max particles. Take that. This should work. If it doesn't work, it's something wrong with how we're probably initializing. Ndrom. Yeah, we need to update this. So we don't need that. We could have... that'll decay into a pointer. So we can just pass that in as is. Let's see if this works. Cube is working. We aren't scaling it, and that's fine. But this works. And we're not constantly... I ever tried creating Windows 132 API, Red Book, or Super Bible. I've never read either of those books, and I've never tried creating Windows using Win32 API. No, I use GLFW. That's my go-to. But this is great. We've achieved the very beginning of particles. We can now actually go back to above the terrain with this. Let's see. Yeah, there we go. And that cube. Now let me think. We have a fixed number of transforms we can work with. We have 25 transforms we can work with. How are we going to do this? Ideally, we should be allocating those. I don't want to have to dynamically allocate these things. This will mean every particle system has to have 25 particles coming out of it. Will that work with our engine? Like, let me think. Is there any reason we couldn't do that where every particle system just has 25 particles instances? We need exhaust for the plane. We need those things that fly over the corners of the plane. Explosions. Well, I'll try integrating CUDA for particles in your game. That's way more than we do not need CUDA for particles. CUDA is just general purpose GPU programming. If I had something that I needed to be massively parallel, that I could, I already have. Also, CUDA I don't think works in the browser. This is a browser game. But yeah, CUDA would be very overkill. So no, I have no intention of working with CUDA in this project at all. Let's see. What? The explosion might be tricky using 25. I feel like setting a fixed number of particles is risky. But I can always rewrite it. Well, regardless, I sadly have to get off the stream now. I have somewhere I need to be. This is good progress. We didn't add any terrain. We didn't add any terrain fog. I'll add that later. All right. This was fun. I'll see you guys. Peace.